All right. Hopefully this is recording. Cross my finger. Okay, so today what I'm going to do is trying to understand this hash function. It's part of the Bitcoin. Trying to understand how Bitcoin actually works, the mechanics and all the nitty-gritty. So I'm kind of like taking this kind of read along from this guy from the website nakamoto.com from Harap Qureshi. He's a kind of Bitcoin guy. So okay, so hash function. I learned a lot from how the picture works. So a hash function is basically it's a function, right? And it's a mathematical function, but for a specific use case. The use case of a hash function is basically it's for to um, to make something secret. Okay, so I have to explain that better. So over here, if you look at the images here, the GIF images or the short video, there is what do you call it? String, right? Or number, hello 42, whatever, right? We just call pre-images, and then it goes to this. Sorry about that. That's my 30 minute I'm supposed to move. Um, so anyway, so so the pre-images value is gonna go into this kind of black box, which is called a hash function. Uh, think of it as a mathematical, it's a specialized mathematical function. And then it goes through it, mathematical function is like y equals to 2x plus 5x squared times 3x, something like that, right? It goes through that function, and the output, it's called a digest. The output, it's a specific um output that kind of like random things. So it's like has nothing to do. If from a layman terms, is the output from the hash function is like nothing to do what's or there is no relationship at all from the input, right? So for example, from here, 42 goes into the hash function, the output is like 92 CF CEB 39D5 blah blah blah. Hello, the output would be F7FF, I love dogs, whatever, right? And then if you notice, it's a specific length. So and this hash function is basically used in one of the Bitcoin puzzle that we're trying to understand. So the one that you need to know right now is there is a pre-images, which is the input value. There is the machine here, which is called the hash function or mathematical function, and the output is called the digest, right? And then there are some characteristic for because remember I said that this is a specialized mathematical function. What make it special, right? And it's called a hash function, right? So okay, so one more thing before we go on, the output itself is can be also called hash. So it can be called digest or it can be called also hash. Um, the famous hash function or uh, mathematical functions is kind of algorithm, right? It's a mathematical function. The famous one or the common one that probably you ever heard is called SHA-2, MD5, CRC32, SHA-256. If I'm not mistaken, SHA-256, it means the output is 256 bits, I think. I'm mistaken. So anyway, we are going to go into the three main properties, three main characteristic why this mathematical function is so special, and it's called a hash function, right? First, they are deterministic. So what it means is given the same given the same input, right? If you put hello, the output has to be always the same. If the output is 7DFFEBABC, if you keep on putting the same input, the same hello, right, as an input value, then the output would be always be what, F7DFFABC, always. So that's what it means to be deterministic, right? Then that's basically it's also, you could say, uh, is a characteristic also of any mathematical function. So it doesn't have to be special, but can be any mathematical function. If you put the same input, the output has to be the same, right? Given the same input. Um, so it says here that the digest may be random looking. I'm just going to make it bigger. Could be random, but it's completely deterministic. So if you put foo, the output should be like that. Okay, forever and ever and eternity, right? Eternity, yes. And so that's the first one. Nothing so special about it, I would say. Um, and then the second characteristic is has a fixed output size. So I have mentioned this, the SHA-256. It's the output is going to be 256 bit, right? 256 bits, which means what's that? Like 8 byte? I don't know. Two to the power. I'm not sure, but it's 256 bits. That means the output could be like 101010 until 256, right? You know what I mean. Um, the different hash function have different output sizes. Right. So like MD5 digest always has 128 bits, right? SHA-1 is 160 bit, right? So different algorithm, different mathematical function, I would say, has a different output size, which is understandable, right? Um, Another way to think about a hash function is like a machine that process something, right? If you think about if you're like mechanically inclined, is a machine is basically to process something. So if the input is like a bread machine, for example, the input is like water, flour, and yeast, and the output is going to be bread, right? But you can put on the ratio of how much ratio of the for those who are making know how to make bread, the ratio of the water, uh, the flour, and the salt and the yeast. It makes a different kind of bread, right? So it's like that. Um, but this is a mathematical one. Uh, Third, oh, sorry. So the first is given the same input, always the output is the same, deterministic. Okay, no problem with that. That's kind of very uniform. Even I think I would argue even our ordinary mathematical function would have that characteristic. The second one I think is more specialized, which has to do with why it's called a hash function, not just mathematical function. That uh, a hash function or a special mathematical function has a fixed output size. For SHA-256 has 256 bits. For MD5 has 128 bits. For SHA-1 is 160 bits, right? That's the example. So the output is fixed for a specific uh, hash function. Third, this is the one I'm trying to grasp, that the hash function should be uniform. Meaning the digest, which means the output, when you say digest is the output, um, should be distributed uniformly over the output space. So imagine a histogram of your output. You want your digest spread evenly across all possible values, all values. So I think I know what it means. So for example, if you have we're talking about the all possible output, right? So like this 92 CFCB. So the output is basically the range of the output is from 0 to 9 in terms of number, and in terms of alphabet is A to Z. So what? In terms of number, there is 10 possibilities, right? Because 0 to 9, that's 10 possibilities. And in terms of alphabet, is 27 possibilities, which is A, B, C, D, E, F, G, H, I until Z. So if you think about it, the permutation of combination is a lot, right? Because it's a mix between alphabet and numbers. What do I call that? Alphanumeric, probably. So I don't know how many permutation is that, but what the characters, uniform characters is saying basically, um, if you give a lot of input, different input, okay, not the same input, right? Different input, the output, right? In an enough like if you give enough like uniform, I think probably enough uniform like different kind of input, right? The output, if you chart it on the histogram, let's say uh, how many times number one occur, how many times A occur, how many times B occur, like the histogram. It has to be kind of like kind of flat. It's gonna be the same. It's not gonna be like it's not gonna be like like a roller coaster. It's not gonna be like probably like a what do you call that? Like a bell curve, like a mountain. It's not gonna be inverted bell curve like a U shape, right? It's gonna be more like a flat because it has to be uniform because the number of let's say number one occurs is like if it's 10 times then the number of two occurs is about 10 probably 9 or 8 the number of times that 3 occurs should be like 11 12 the number the character A occurs is like 11 so it's more or less the same like probably like within 10%. I'm not sure but I think that's what it means by um, the digest should be distributed uniformly over the output space, right? So if the output is within 0 to 9 and A to Z, then that that space has to be uniformly distributed. It's not like, oh, you are the best character A, so I'm just gonna have my output favoring to A. So all of my output will have A, like 92A, 37A, 15A, 30A, 35A, 38A. So it shouldn't be like that. There shouldn't be a favor child, to speak. Everybody's kind of the same, right? That's good, right? There's no uniqueness in everybody. Everybody's the same, right? So it's like, anyway, I'm talking about like uh, people are different, but in a way, people are the same. That's like a dichotomy, right? I mean, we have our own like predisposition. I'm talking about psychology right now, but anyway, so whatever. I hope you understand that the meaning of uniform, right? Um, so so you want your digest spread evenly across all possible values. Yeah. So I think now I get what it means. Yoo-hoo! I got this. So, all right, we're gonna try this simple command, right? We're gonna run it on the REPL. If you don't have REPL, go to REPL now and then just sign up. It's free, right? And then just run it and then go to Python. So you go to REPL over here, right? Create an account and then create a REPL. Click the Python. Click this, right? And then you're here. You're in this space here. And then you just copy and paste that code over there, right? And then you can run it, see run it, but it doesn't work because wait, hold on. No, it should work. Wait, why is it doesn't work? Oh, wait. Oh, I think you have to print it. Yeah, you have to print it. I'm just gonna close this. Oh, I'm just gonna, yeah, you have to print it, right? So, oh, and then you run it. There you go. It's working now. Okay. So, um, this is how it works, right? So this first statement is basically from the library of hashlib. Is I think it's a library compilation of all the hash function. import a specific hash function, which is called SHA-1. Remember, SHA-1 has 160 bits, I think, right? It says here 160 bits. SHA-1 are 160 bits. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. Oh, 40. 40 times 4, I think. Because this is a hex digest. Hex digest. It says here hex digest. Um, so let me see. Uh, SHA-1. Yeah, so in a hexadecimal. I wonder if you hex hex is a let's see hex digits. So base 16, whatever. I'm kind of confused. So yeah, I wonder if you can do this hex digest. SHA-1 has object. Okay, so you have to specify the what kind of digest you want it to be, right? Oops, oops, thing. Oh, why it doesn't work? Okay, so this is 40, like 40 characters. I think each of the characters represents a 4 bit, right? If you do SHA-256, SHA-256 is what is SHA-256? It's 256 bits. Um, let's see if it works. SHA-256. Okay. Okay. That's more, right? I don't want to count that. I'm just, do I have to count it? Oh my gosh. That's crazy. One, two, three, four, five, six, seven, eight. I don't want to count it. No. Just SHA-1. 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 Or probably I can notice where it stop here. Somewhere here. If I do this, okay, I wanna put my cursor here and then I wanna run it. But how do I do that? Like here. Oh there. Okay. So 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 64. 64 times 4. I think 64 times 4. Yep, it's 256. So that's correct. So each of this number or alpha represent 4 bits, right? So because this is their 64 character alpha or hex. Um, I don't know why it doesn't represent a byte. Yeah, I'm not sure about that. But anyway, so this is just playing around with this algorithm. Um, and again, and then here we have 40 kind of alpha hex digits times 4, 160. So if you change this, then that should change, right? Right? Because and that's basically the definition of a deterministic. For every input, it has a specific output. And then the second characteristic is um, what is the second characteristic? I forgot already. Deterministic, um, which is pre self-explanatory. The a fixed output size. Okay, fixed output size. Yeah, that's kind of sex explanatory too. Okay, so for SHA-1, the output size is always 160 bits. In this case, it's represented by half a byte, kind of. Yeah, so it's 40 by a hex digest, whatever it is. Okay, I think. Um, so that's the second characteristic. For a specific algorithm, it has a specific output, right? Uh, so um, it's called fixed output size. And then the third characteristic is uniform. So given the digest, given the output, right? The range of output that could be there, in this case, I already mentioned it, like 0 to 9, like the numbers, and then the alpha is A to Z. Uh, if you keep on giving different inputs, given different pre-images, then the range of output will be uniform. So that's the third characteristic, right? So the digest should be distributed uniformly over the output space. Imagine a histogram of your output. You want your digest spread evenly across all possible values. So yeah, I hope that's clear. That's for now. And that's just about what is hash function. The next session, I'm trying to discuss what is a cryptographic hash function, which is a continuation of hash function. So remember, so if you want to think about a mathematical function, right? Hash function is basically a specialized mathematical function which has that three characteristic. Has to be uniform. The digest, the all possible output uniform, has fixed output size for a specific algorithm, and the third one is the deterministic, right? Given a specific input, the output has to be specific, right? So those three make it kind of a hash function, also specialized mathematical function. Next, we're gonna go even deeper, which is the cryptographic hash function, which is a more like specialized mathematical function, right? So when you say hash function is already a specialized mathematical function, cryptographic hash function is more even more specialized because even more a subset of the hash function, and because of that, it has a certain characteristic. Otherwise, it wouldn't be so special, right? All right. If you say like, oh, that person is special. Why? You have to think why. Why is he special? Oh, because he can jump like 10 meters high. He can like memorize like 20 random numbers in like 5 seconds. Or because he can, blah blah blah, right? So you have to when you say somebody something is special or unique, you have to kind of ask the question why? Why do you call him or her, or why do you call that thing unique? What are the characteristics? So, yeah, remember those three. uniform all the possible output values, the digest, um, fixed output size, right? For a specific algorithm, SHA-1 has 60, sorry, SHA-1 has 160 bits, SHA-256 has 256 bits, and so on. And so fixed output size, uniform, and deterministic, meaning given a specific input going through the machinery of the hash function, the output has to be also the same, right? It cannot be changes, right? It has to be the same, right? So if you put hello, the output has to be if it's AFD, then if you keep on putting hello, then the output will be AFD. Think about bread when you're making a bread. Those who make bread or those who cook, given a specific recipe, the output kind of is a certain dish, right? If you change the recipe, the input, then the dish would come differently. So yeah, I hope what else I want to say. I think that's all for now. I strongly suggest you go to Rapplet, and then go to that website, this website, nakamoto.com, yeah, over here, right? And then take the course. Uh, and then probably you can do something like this. I don't know. I'm not really particularly smart. I have to kind of explain. This is a way for me to learn as well to share whatever, and hopefully make a little bit of money from YouTube, whatever. So yeah. So hopefully this has been useful for you. Again, thank you for listening. I want to hear your comments. And for those people like subscribe to me, I don't really know why you're subscribing to me. So if you can like just give a comment, I would truly appreciate that because I know what you are in my channel for, right? And then give like comments like what's good, what's bad about my video. Um, um, okay. I'll see you on next video. Ciao. Do I click this? Stop recording.